Hello guys, this is Andrea and today we're gonna learn how to do a descriptive statistical analysis in R. Descriptive statistics is a branch of statistics that deals with a collection, analysis, interpretation, and presentation of data. The aim of descriptive statistics is to describe the main features of a dataset by using measures such as the mean, median, mode, range, variance, standard deviation, among others. This information is so important to know because it provides a basic overview of the data and it helps to identify potential issues such as outliers or missing values that may need to be addressed before further analysis. For example, imagine that you have a franchise and you want to know which store is the most visited by customers. Knowing the average number of visitors in each store, you can know which of them is the most popular and make decisions based on data. We can get these measures in our programming language, which is a powerful tool to analyze data. R is widely used by data scientists, statisticians, and researchers for a number of reasons. One of them is that it's an open source software, which means that it is free to use and can be modified and distributed by anyone. It also has libraries that allow you to create very beautiful graphics. In this tutorial, we're gonna get measures of central tendency, as well as histograms and box plots. An histogram is a representation of the distribution of a set of continuous or discrete data. It is a graph that shows the frequency of occurrence of a range of values in a dataset by dividing the data into bins and plotting the number of data points that fall into each bin as a bar. The height of each bar represents the number of data points in the bin, and the x-axis represents the range of values in each bin. A box plot, also known as a box and whisker plot, is a type of graph used to display the distribution of a dataset. It displays the median, quartiles, and outliers of the data in a compact format. In a box plot, the main box shows the interquartile range, which is the range between the first and third quartiles. The median of the data is shown as a line inside the box. The whiskers extend from the box to the minimum and maximum values, excluding outliers, and outliers are plotted as individual points in the whiskers. Histograms are useful for quickly visualizing the distribution and skewness of the data, and box plots for identifying outliers. So let's begin.
And we have to call for the libraries. And these are three libraries. We have to create a vector, and these are tidyr, aspects, and tidyverse. Then we call the packages without quotes. And then we're gonna use the iris dataset and assign it to a variable, name it data. And a quick summary. And we also can use the next procedure. And we get more values, like for example, the number of values, and these are 50, the number of null values, the number of NAs, the minimum, the maximum, the range, the sum, the median, and the mean. The standard error of the mean, a confidence interval at 95%, and the variance, the standard deviation, and the coefficient of variance for Setosa species and versicolor and virginica. And if we want to get a more visual information about this, we have to transform the data to long format. Before we plot this information using ggplot. Using the function pivot longer, and we get the long format of the data. If you see here, we have the species Setosa and the characteristic gathered together here, the sepal length, the sepal width, and the petal length, and the petal width, and the value for each characteristic of the species. And the next thing is to graph with ggplot. And we use data long, the aesthetics are x, values, and we're gonna plot an histogram with the default features, and we are going to facet grid the rows as the variable species, then the columns as the variable characteristic. And here we have histograms for the petal length of Setosa and the petal width of Setosa, sepal length and the sepal width. And we see here an skewness to the left, the petal length to and the sepal length to the right, more to the right. This is more like a Gaussian petal. And the versicolor, it's kind of different from the petal length. Then if we want to plot the box plot, we have to do kind of the same, but changing some arguments here. So in the x-axis, we have to indicate the species, and in the y-axis, the value. With the default characteristics. We're going to facing to and indicate that we want to have the characteristic in the columns.
Well, I hope this video helped you to have an overview of your data using this lovely programming language. If you have any questions, any comments, please comment below. I'm here to help.